Oh, yeah, sorry, of course. Hello, everyone. Now with the voice. Welcome to the today's session on JavaScript as a part of our tech meetups at ING. Today we have two talks dedicated to JavaScript on the server. And first one going to be by Luca, a developer who works on a Deno project. Deno project is an ambitious attempt to reimagine Node.js with a better, which will be better in many ways. It's built on top of V8 and Rust. And it got a lot of attention recently, so I hope Luca will walk us through the features and capabilities of this engine. Before I pass it over to Luca, I will just wanted to mention that for your questions, please put them in the YouTube chat. Because of the delay, it's not possible to answer them along the way, and we will summarize them, and Luca will answer them after the talk. So good luck. Really looking forward for your talk, Luca.
Hey everyone, I'm going to give a talk on Deno today. I'm Luca. I work on the Deno project together with Ryan and Bartek and Bert and all kinds of other great people. And I'm going to give you a quick introduction of what Deno is today, how it compares to Node, and we're going to do a quick live coding session, a little bit of an example of what you can do with Deno. So let's get started. Deno is a modern server-side JavaScript and TypeScript runtime. So like Node.js, but it is secure by default. It's one of our goals is to be to leverage V8's capability of sandboxing your code as best as possible. So by default, your code has no access to the network, no access to the file system, no access to your environment variables. Everything has to be granted explicitly when you start your program. So you can run any random code from the internet, and you can be pretty sure that it's not going to delete your, I don't know, like entire disk without you giving it permission to do so. Deno is web compatible where possible. So we try to use web compatible APIs where we can. We have APIs like alert and confirm and prompt and fetch to do HTTP calls, qmicrotask, Node, which Node doesn't have. We have timing APIs, and yeah, all kinds of other fun stuff. And we also have an extensive standard library. Our standard library contains all kinds of stuff that you would usually need to pull packages from NPM for in Node. So for example, UUID generation or hashing, YAML decoding, an HTTP server, utilities like delay, for example. So being able to just delay something by X amount of milliseconds asynchronously. But Deno is not just a modern runtime for JavaScript or TypeScript. It is a full toolbox. It contains tools like a formatter, a linter, a test runner, bundling, documentation generation. So formatter, for example, you might use Prettier in Node. That's all built in. And our linter can do pretty much everything that, or can do the entire default rule set of ESLint. Our test runner is capable of running tests, which is great if you're trying to be a test runner. We can do bundling with type stripping since the late, or if you wanted to use TypeScript, JavaScript or TypeScript and create a bundle. We can do documentation generation. So you can pass us a module and we will tell you all of the symbols that are in that module and give you the descriptions based on the JS doc. So we're not just a runtime, we're really a full toolbox. So everything you could need when you're building an application, we've probably got you covered. And the best, or one of my favorite parts, is that we're actually a single file. So Deno is a single file. It's about 50 megs, and you download it and you run it, and there's no DLLs that you need to install. There's no folder that it like comes along with the download. It's a single executable, which is great if you're trying to run on Google Cloud Functions or in a Docker container or AWS Lambda. You don't need to have a complicated install. You can just fetch the executable and run. So why even bother building a new Node? Node is very popular. Node is used by thousands, millions of projects, millions of developers every day. It's got a huge ecosystem with NPM. But Node was built in 2009, and there's been many innovations to the JavaScript ecosystem since then. So Node has many proprietary APIs, like buffer, for example, whereas on the web, we would use typed arrays. So typed arrays are like uint8 array and array buffer, data view, things like that. And also Node uses callbacks instead of promises, because back when Node was designed, promises and async await wasn't a thing in JavaScript. Those came in ES6, which only came around in 2015 or so. So Node misses out on like many features that are in JavaScript now because it has to support this legacy API. Which is great for stability, but if you try to be web compatible and try to do things in a very web-centric way, and if you're a web developer, it might be difficult to get into Node because you have all these concepts which seem rather dated if you come from like modern React frameworks or things like that. And also Node has a single central package repository, which isn't very webby. On the web, we like to have all of our dependencies be distributed. So we have CDNs to serve files, and there's no central authority which gets to decide if you get to have a website or if you get to have a package or how many versions you get to have. It's everybody hosts on their server or on public cloud. And Node doesn't really take that concept, or it doesn't really have that concept. Node has its own module resolution based on package.json and Node modules, the Node modules folder. But Deno instead just uses the web standard module resolution algorithm. So we just fetch things from a URL, and then we cache it locally, and then we run using that. And also, if you come from web development, because of all these things which seem rather dated if you're a web developer, like callbacks and buffer, the curve for learning Node might be rather steep. And you need to install many dependencies to get a project up and running. So you need to install ESLint and Prettier. And if you want TypeScript, you need to install TSC. And you need to understand how all those tools work before you can actually start using Deno or start using Node to its full potential. And with Deno, all of that's built in. So here's a comparison. Here's a comparison between Deno and Node. We use V8, the V8 engine for running your JavaScript. Deno is written in Rust, Node's written in C++. We use the ES module syntax. So we don't use common JS like Node does. So there's no require calls. Everything just uses import and export, which is the standard JavaScript way of importing and exporting things. And we use the web standard module resolution, as I previously said. Also, our API surface is a lot different. We have web APIs, which are just available just like in the browser. So fetch and set timeout. And then we have the Deno global. The Deno global contains everything that's non-standard. So reading disks or reading files from disk, reading environment variables, starting TCP sockets, things which wouldn't be secure to do on the web, which is why they're not available. And then we have the standards library, which contains all this auxiliary stuff, like the YAML parser and things like that. And the standard library is fully written in TypeScript, and it's just another module that you import. But it is like maintained by the core Deno team, so it's stable and it's tested, or it's not stable yet, but it's tested, and it's very, very useful. And then Deno has all this development tooling, as I mentioned previously. Something I didn't mention was the version manager. So Deno can upgrade itself, it can update itself And in Node, where you might use Node Version Manager, for example, you can just run Deno upgrade -- version and install a specific version of Deno using Deno itself. So there's, again, something you don't need an auxiliary tool for. And probably my favorite part is that Deno runs TypeScript out of the box. And I'll show how that works right now, because we're going to do some live coding. So we're going to write a little CLI tool, which gets the weather report for where you're located at, or for the city that you enter. So the user enters a city. We make an HTTP request to the Open Weather Map API. We parse the response, and we display the report to the user. And we're going to do this in TypeScript, and I'll try to show you some of the nice tools that Deno provides, so formatting and linting. So let's get started with that. I have the VS Code window here, and I've created a file called main.ts, and I also have the Deno extension installed. If you want to use Deno in VS Code, I'd highly recommend you install the extension. It allows you to, it makes sure that like all the imports work and that TypeScript like properly works. So yeah, I suggest you install that. And then I have this settings file to enable the extension. Cool, so let's get started. So we want to start out by prompting the user for the city they want to get the weather report for. So we can do that using the prompt API. Deno has the same prompt API as the browser. So you can pass it a message. So let's prompt, what city do you want to get from? We're going to assign that to a variable, city. And let's run that, Deno run main.ts. And you can see it compiled the TypeScript and no errors, and we're running the script. So let's enter, and we don't do anything with this, so we just exit. I'll show you that TypeScript actually works. If I enter 1, 2, 3, or that here, first of all, TypeScript or VS Code is going to complain because this is not a string, and it should be a string. If I run this, it'll refuse to run because it only wants to run string. It wants to run. This should be a string. Cool. So let's log out the city to make sure this works. Deno run, yes, and it logs out the city. So that works. Now we need to actually fetch the weather report from the Open Weather Map API. We can do that using their API, which do by calling endpoint with the city you want. So let's say like New York, and then an API key. And this API key I have stored in a environment variable. Have fun with it. I don't care if there's no billing account linked to it. So, so first thing we need to do is get this API key into Deno. So let's use the Deno environment variable API for that. So there's this Deno global, which has this get API, and you can use that to set environment variables for your running program. So OMW API key, that's going to be assigned to the API key variable. And if I log that out, console.log, and run that again, run that again, you're going to see it's work. You can see that if I try to do that, it doesn't work because we didn't actually grant Deno access to read from the environment. So let's pass the allow env environment variable. Let's see how it works. Cool. So let's construct this URL that we want to fetch from. It's Deno FMP. Formats it. And pass the API key in here. And then instead of hard coding the city, let's actually use city. But we don't actually just want to pass this in like this because it's in a URL. We need to URL encode it. So we use the URI encode component function, which is available in Deno. And it's actually, we have this website called doc.Deno Land where you can browse the whole Deno runtime documentation and see which APIs are available. So for example, if we...
Luca, can I ask you quickly to zoom in a bit?
Sure.
Maybe
Yeah.
2-3 times? Yeah, maybe more, one more. Yeah, perfect.
Sorry for that. Okay, let's zoom in here as well. So this encode URI component function, you can see that it's, no, maybe not. Okay, well, it should be in here, but I don't know, it's probably somewhere. Cool, let's console log this URL that we construct. Validate that it works. But you see, it doesn't. This is another TypeScript thing. You can see that this prompt, it returns either string or null. And this encode URI component function takes a string, and it doesn't take null. So we need to make sure that city is null. So if not, if we don't pass the city, we want to console the error and say pass the city. And then we exit with exit. So run this again. You can see it compiles, and now if I run this, you can see the API, the URL. And if I try to curl this now, you can see that we get the weather information. This is working. Let's actually do this API call in Deno now. Use the fetch API for that. So there's the fetch API that's also available in the browser. And you can see that fetch a resource from the network. It returns a promise that resolves the response to the request. And the request is specified by this input field, which is the URL that you want to fetch. Let's do that. Let's assign that to a response variable. And we can use top level await. This function returns a promise. So we need to use await to actually get the result. And you can see we're not inside of an async function, but because Deno supports top level await, we can just we can use await anyway. So let's do that. So log response dot and let's run this. And we'll see that this still doesn't work because we need to pass the network tag to allow network access. And we can actually even limit this somewhat. If we don't trust this code, let's say we only want it to be able to fetch from Open Weather Map API and nothing else, then this is going to lock it down to only be able to fetch from there and nowhere else. Okay, status code 200, that means okay, success, the HTTP call succeeded. Let's get this is JSON data, so we're going to get the JSON data out of the response. We need to top level await again. Let's console log that. Console log the data. Let's just run. So what city do you want weather for? New York. Cool. Okay, so we have a JSON output now. You can see the name of the city. Here's the minimum temperature, maximum temperature, the description of what the weather conditions are like. Let's print that for the user. Let's start by just printing out the name of the city. So New York. And then let's also print out the maximum temperature. So we can do that using so this is stored inside of the main and then temp max. So data.main.tempmax. And then if we run that, see, we get a result. This is currently actually just Kelvin. This API returns its data in Kelvin. We want it in Celsius because so let's back 273 from that. Kelvin minus 273 is the degrees in Celsius. And you can see this works now. It's currently 20.7 degrees in New York. I don't know if that's true. If anybody's in New York, you can put that in the chat. And we could do the same for the minimum temperature. Let's do that. New York. And it's 80 degrees low. This is currently printing all kinds of numbers, a very long number. Let's cut this down to something more reasonable. Put here, if we have some time left, maybe we can clean that up later, but good enough for now. Okay, cool. So now this logs correctly. Let's try something else. Let's try Amsterdam. 8 degrees, that seems very reasonable. Let's, who else can we look up? Sure, also works. So this is, as you can see, very simple script, 18 lines, and we have a weather report with fully functioning. And the best part is we had to install a single executable for this. Only the Deno executable and everything else just works. Right. And another great part is this all uses standard browser APIs. So what we can actually do now is if we get rid of all the calls to Deno, so let's, instead of using Deno here, let's do window.close. And put this all into an else statement to make TypeScript happy. And if we hard code the API key, so that. And run that again. Yes. And I could bundle that, Deno bundle, or into a JavaScript file. A single JavaScript file with the bundle in it. And we can create a little HTML file here, which just imports that. So script bundle.js, and it's a module file, so we need to specify that. And then if I sort that, and I get asked in New York. Now, if I inspect this, no console, you see it works. So this is something exact same code, runs both in Deno and in the browser, no changes. Well, pretty much no changes, which is pretty cool. About this again, and I'll demo some of the other features. So Deno has the built-in linter. Let's change this to a let. And then the linter is going to complain about that. And you can see data is never reassigned, use const instead. Again, that's all part of the same binary, no extra installs required. You can also run Deno info, which prints out a list of dependencies. There's none currently, but we could add some dependencies as well if we wanted to. And then I showed you bundle already. There's all kinds of other stuff as well. There's FMT and I just showed you that. There's Deno install. Let's actually show you that. So let's say I want to just be able to run. Let's quickly clear this. Let's say you want to just run this app using just calling weather. That currently doesn't work. You can install this app. Install name weather, and we give the permissions again, so it saves them, and the entry point. We install that. Boom, and now we can just run at wherever we want on the system, and it just works. So if I cd back one directory, it's still going to work. And there's our weather report. Cool. So that's my little demo of using Deno. If you want to get more information on anything related to Deno and how to use it, make sure to check out the manual on the website. There's an introduction here, and how to get started. How to do imports is also here. I didn't show you that, but it's very simple. You just import files as usual. Right. So let's get back to the presentation. So that's the little live coding session. There's all kinds of people that work on this. There's these, but then there's 495 more more every day. So if you want to join in, join us on .com/Deno Land here. And there's something for everybody. If you like working with V8 directly, then there's this Rusty V8 crate. And if you want to work on the CLI crate, there's the CLI. Right, and yeah, that's pretty much it. If you have any questions, make sure to leave them in the YouTube chat, and I'll try to answer them in a moment.
Thanks, Luca. So let's get to the questions. I think there are some in the chat. I'll try to show them one by one so that everybody can see that. First question from Maurice. Are you able to see it?
Let's see. Yes. Maybe if you disable my screen sharing.
Yep.
Otherwise, we get this recursion. Sure. Cool. So what do you expect from Deno in the future? Any roadmap? Yes. So one of the features that's going to be coming up soon is we're going to be stabilizing the linter. And we're also going to be adding web GPU support sometime soon. So if you like working with TensorFlow, for example, you'll be able to use TensorFlow in Deno, hopefully, without any plugins or special native stuff. You can just use the web GPU API, which will be kind of cool. And in the long-term future, there's always stuff to do. We want Deno compile to be a thing, so just compile your TypeScript code into a single executable, which you can deploy to your users. Canvas, I see you mentioned Canvas. That's also something that, part of web GPU that's probably going to be coming at some point.
So it will be also, the Canvas will be like a pluggable module.
Well, it'll be, so web GPU is just going to be the web GPU global, and then Canvas, we're not really sure. It's like we haven't started on that yet. Yeah, but I think there's an issue about it on our issue tracker, and if you want to look into it, you can go there, take a look at that. But yeah, we're probably going to be working on that at some point as well.
Okay, and you have something like a roadmap page where this all is aligned, or it's more in kind of in the issues and in some internal chat discussions?
We have, right, I didn't mention this. We have a GitHub, we have a Discord channel, a Discord GG/Deno. You can join us there and we discuss, that's where most of our discussion happens. But our issue tracker is pretty much our roadmap as well. There's a pinned issue right now, which is the roadmap for the next, for like until the end of the year. Yeah, you can take a look there.
Cool, thanks. Another question by Julien. It's about the coding sample that you were showing.
Yeah, sure, I can explain that. So the difference is that the Node TypeScript example, you have a package.json file and your Node modules folder is like probably over a gigabyte in size. And with Deno, all of this comes in a single executable, and there's no need for the user doesn't need to know what TypeScript, or doesn't need to know how the TypeScript compiler works, for example. That's like all abstracted away from you. So I think it's a lot easier to get started with, but that's obviously up to everyone. So
yeah, I just found the link to the Discord chat, so I've pasted it in so that everybody can join. A question that I had, so more about if I'm using Node to run various build tools and stuff, more like for front-end projects, can I just switch it relatively easily and get a better performance, better security and stuff?
Not really. Deno is not compatible with Node directly. We don't support Node modules. We don't support this Node module resolution. That's something I didn't show now, but we use the web standard imports, which Node doesn't support directly. So we don't have require as well, so anything that uses require won't work. But we have a shim in the standard library called std/node, which emulates the Node API as best as possible to do things.
Okay.
Maybe.
Okay.
But there's some front end tooling for Deno as well.
Okay, so it's going to be like a separate ecosystem in that sense.
Yeah.
Okay. Okay. Next one, it's also by Julian about the compilation process, which I think is also part of the pipeline for Deno project.
Right. You mean that it compiles the TypeScript automatically? Right.
So besides TypeScript, I guess, is there any other steps in the process, or it's just transpiling TypeScript to compiling TypeScript to JavaScript? That's the only problem.
Yeah, that's the only. Well, what we do internally is we have the TypeScript compiler, which type checks your code, and then we have a highly optimized Rust path to type strip your code. And our type stripping code is, I think, 10 or 20 times faster than TSC. So if your code's already checked, startup is pretty much instant.
Okay, clear.
So there's no extra step.
Okay, thanks. And one more by Maurice about the import maps.
Yeah, import maps are supported. They're unstable. We're going to stabilize them most likely when browsers do, but browsers haven't stabilized them yet, so we'll see. But they're behind the unstable flag. You can use them if you want.
Okay.
And if you don't know what import maps are, they're in the documentation as well, the manual.
Clear. Thanks. One more by Oliver for loading custom stuff.
Yeah, that's actually been a very long-running question. We've wanted to have a sort of compiler, like module loader API, for a while, but there's nothing concrete yet, and there's a few issues open about it. I would, if you want to know more about it, I'd come to the Discord and we can chat about it. But it's very complicated. Yeah, it's not supported right now.
Okay, clear. Yeah. Once again, thanks, Luca, for a nice demo for the slides. I think it gave us a bit better understanding what is Deno and what you can do with it. Thanks. So we'll be switching to our next speaker, and second talk today is by Remco. Remco is a colleague of mine from ING. And he's been working with Node.js APIs for years. And today he's going to present us a bit more on using TypeScript in Node.js API apps. So the floor is yours, Remco. I'm switching you the slides.
Okay, thank you, Miguel. Good evening, all. Yeah, here I am. I'm gonna talk tonight about a few things about how we got Node.js started within ING, what we did, how we structure our apps to make it usable within a company as big as ING, and why we decided to add TypeScript or switch to TypeScript, depends on how you look at it, in the long run. Just a quick standard intro. Like as Mikael said, I've been working at ING for quite a few years. When we started this project, I did a slight detour in between, so dropping off the project to do a short-term assignment in ING Australia. And then I came back and currently part of Atomic Kittens at ING Tech, which is a global part of ING, where I got back to the same API that I started years before. And that's where it currently still resides. So let's go back a few years, because this project started a long time ago. Well, 2017, depends on what you see as long, right? Back then, the active LTS of nodes was still 6. So that's, as Luca said before, with the lovely callbacks and stuff like that. So that's been a while. And a new project is about to start up in a team that is mostly consistent of JavaScript developers that worked on build tooling and front-end components itself almost fully. But as you might know, many big companies are very JVM based or .NET based. And in ING, that's no difference. It depends on which entity you are within ING, if you're either JVM or .NET based. So that's also a preferred stack for all the different new applications that you start and you're making. So Node.js was not on that list and wasn't a priority back in the day. However, because of the fact that we were a front-end build pipeline team with a front-end in front of it as well, but we needed to deliver all the different aspects. That means there's a lot of JavaScript knowledge required. And with a team of only 4 or 5 developers back then, and a very hard time to find people that had web components knowledge, which we just started to adopt as ING, and also have a very good Java base. It's very hard to find, or was very hard to find, developers like that back in the day. That did not go well. And at the same time, we as a team believed and still believe that Node.js is capable of running a API in the backend as Java or .NET is. Luckily, back then as well, ING was already starting with the with a more emphasis on internal open source model, especially for front-end components, but also already for backend tooling, which means that a lot of things have to be shared and reused by each other. And what it also meant at that time that Netflix came out as well openly that they were using Node.js for their new tooling, etc. So that was a big eye opener for ING as well to be say, let's give it a go and see how it goes. So that's why we came up with Node.js and are still using Node.js, because it just worked. Just a small overview of what is the stack in order to give you an idea of the complexity or what kind of different things we are doing. So we are just running a Node.js server, or multiple Node.js servers in production with PM2 to keep everything running as a service. So when you redeploy your application, it's just running already and you don't have to do anything yourself. If it dies, it starts up again, etc. Back in the day, we wanted to have a lot of WebSocket connections to our dashboard regarding the build interfaces. So if a build is running, you want to get real-time updates on what's happening with your build. And out of the box, back in the day, ReachingDB gave that as a good database solution. I don't know if many people have heard about it, but it works pretty well, and it has out-of-the-box WebSocket support. That's why we went for it. Besides that, we use certain Kafka connections to talk to other APIs. But as most APIs within ING are, like I said, either JVM or .NET based, we also sometimes have to talk to different APIs, not through Kafka, but just with REST endpoints. But everything within ING is very authenticated with shared tokens, etc. Everything is secure, or has to be secure, because I mean it is still a bank, right? That's why a Java sidecar is being used, which basically gives us all the benefits of either instead of using a base layer on the Java APIs, we just have a sidecar, which gives us the same tools out of the box as that base layer would give. So that means different logging, different authentication models, etc. That's all done for you. And that's also a benefit why they're currently popping up more non-Java APIs within ING, like Node.js, Python, whatever. And besides that, we're using Kibana and Prometheus for our logging and monitoring tooling, which also integrate very well with both the sidecar and just with Node.js by default. I said before, ING is a very big company with many moving parts. I think my journey within ING itself already shows that a little bit, that in a few years you move, well, not just in a company, between teams, or from project to project, but also from country to country, which is a big change, right? And like I showed as well, I didn't start in Atomic Kittens with this API, but in a different team, what means that a lot of things change. This is why you have to make sure your architecture is also based upon this. So you should be able to switch different things, either if the application is being transferred to a different team, or different aspects of the applications itself are being shipped to different teams, or tools around you change. That's all possible, and well, it all happens. So that's why we came up with a layered architecture. Well, we didn't invent the layered architecture, but we used the layered architecture where we have a very defined split in different aspects in what is how we use it. As of course, every Node.js application has an index to start with, which is just your shell of your application. But besides that, we have the middleware layers, which do just some extra layers on top of your Express server that basically says like that you've facilitated security, authentication. In this example, for example, we check if a request uses project data. A project is an entity in our database, basically. We check if it actually exists before passing it on to the next function, so that hasn't been done, that doesn't need to be done anymore, and we can just reuse that data already, instead of all the services and all the different things having to do it themselves, and also already fill early. Well, routes are very specific. If you know, and if you have used tools like Express or anything like it, you know routes are there to just point you into the right direction. So if something comes in on project slash project with a project name and then the quality, we will forward you to a certain function that handles that request. So these are all interchangeable as well. So it doesn't need to know what the function actually does. You can just move it around without knowing what it does underneath, kind of. So you end up in the controllers, as you saw before, where for the quality endpoint, for example, the project details quality report is being called, which again uses the parameters that it gets from the router itself and calls forward to the next layer. The controllers are very slim. They're basically just a grab data from point A and point B and send it back if it is successful or not. And it handles some of the parameters to give them the right order or parse them into different values, etc. That basically goes on to the next one, the services, where we call it the brain of the application. That's also why in the diagram, the services is the bigger block. What the services do is do all the magic or all the logic behind the scenes. It knows where to get stuff from the database. It knows how to do computations. It does all the stuff. This is just a simple GET request I'm showing you right here. So it just tries to find a project, and then from that, all the builds, and gives you back a certain report and formats that for you. If you look to our code base, we have bigger functions here, of course, with a lot more logic that do a lot more than just this simple get. So this is where everything lives that you want to change. And now we have the most frequently changed layer, which is called the adapters, which is basically the gateway to either other APIs, our database, different tools, etc. So the services, for example, they don't care which database is underneath it or which external dependency they're calling. They just want, in our example, they just want to get the build quality reports. Where they're stored in the database, how they're being get, they don't care, because the adapter handles that for them, basically. So if we would say that we're going to switch database, this is the only layer that needs to be changed. The other layers can just perform the same way and don't need to alter any of their code in order to fulfill that change. Or if we're switching different external dependencies as well, an API gets decommed and a new one gets changed, it's an easy change. Besides that, we still have the utilities where I'm sure everyone has them. Your very usable, reusable pieces of code that are the smallest bits and pieces that combines everywhere, which are used in different layers. So let's jump a little bit of time. Now we have a little bit of the idea of the scope of the size of, or at least the different layers of the API. We go 2 years later. I've been around the world from Netherlands to Australia and back. In the meantime, developers as well have, besides myself, have come and gone. The API has transferred teams in between. Node.js has scaled up from 6 to 12 on LTS level. And the first thing, of course, when you get an API back or developers come into a team, they want to change things, right? They want to refactor. And we instantly decided, after having a good look at the size of the code base and what the different aspects did, to introduce TypeScript. For people that don't know, TypeScript is basically a layer around JavaScript to add typings, etc. That's a very, very brief explanation of what TypeScript actually is. But I'm not going to dive into the aspects and details of TypeScript that much in this presentation. But we decided to continue, or at least migrate to TypeScript, because we weren't feeling safe to just say, hey, let's change this code and let's refactor everything because of the scale of it. And also we did already add in the API itself. We used a library called Tinky, which is basically an ORM on top of ReadingDB. What that basically means, it's a runtime type checking. So if you pass in this example, an ID that doesn't match that regex, it will throw an error and you will get that error runtime, so not build time. But this already fixed a lot of our initial issues during the refactoring because of how our test setup was working, and you changed things and it said, hey, this is not allowed in there. And also make sure that you have the right attributes in your database and you're not missing out on certain fields that you actually need. Well, like I said, we were refactoring. And the main reason why we introduced TypeScript is it makes refactoring a lot easier and safer, not just build time, but also while you're developing, because, well, every mistake you make, like you, in this example, the rec is a string. Well, rec, a string object doesn't have a method on it. So you know something is wrong and you're not using the right parameters. And this will always be a very beneficial tool when you're refactoring, because you instantly know if you're doing something wrong and you need to change something. And you're not just dependent on your test or your users on production that are testing your code. Besides that, sharing libraries between applications is a lot easier if you use TypeScript. It has the same, due to the same reason as the one I shared before with you. You just get out of the box. When you add a new library, you don't have to go specifically through the docs to see what's going wrong, because it will tell you if you're passing in a integer instead of a string into your new function that you call. And the same with if you update a version, for example, of a dependency, you will instantly get a notification if something has changed that you didn't expect. Because everyone tries to be proper with their Semfare, of course, but it happens that sometimes something is breaking while people thought it wasn't breaking. And one of the other major benefits that we really liked as a team itself, I know TypeScript is not the only way of getting this feature, but the fact that you can already use the new ECMAScript features that are not in the latest LTS yet of Node.js, but are still under review or are in one of the other phases, that just helped us a lot by cleaning up our code a lot more, and speed us up while doing new refactoring steps, etc. And the next one, as I mentioned before, developers come and go. Developers joining a team with an API that is of a certain size, or just a code base, multiple repos, you try to figure out a way to do your first commit on that code base. Just having types ready for you helps a lot by just, when you're making a mistake. The same as I mentioned before, we have that internal open source model, which was started out for web components and API endpoints, but also for just people want to add and contribute to your API to make your project a better project and help them solve their issues. Helps a lot if you have certain handlebars for them to hang on to and to help them go quicker, basically. So that's the reason why we added TypeScript. Then, as I said, we had already a Node.js API. We had to define a strategy, because it's not just rename everything TypeScript and it's done, because it's a way to do everything in one big blowout, but that's a lot of it could be a lot of work, or no releases in between, and it depends on what resource you have in the team. So we identified two different options to rewrite the whole API. It's either inside to outside or vice versa. What that means is, if outside to inside from our perspective meant you start at where the user is and you work your way to the other side. And what that basically means is you specify what you expect. As you start on the index level, you basically say, well, this function returns a string, or this function returns an object with these fields in there. But the function itself has never declared that. That's something you specify yourself as a user of that function, basically. If that's the reality, that's then the question. Inside to outside means you specify what you give. So it's the other way around. That means that you start at the adapter level and say, hey, this function returns a string or an object, and the other layer then has to handle that object the way they should. We ourselves picked that option, especially because it enables us to keep releasing in the meantime, and it gave us a lot more certainty that we're actually using the functions the right way, because we know what we defined, what the function would return. And that helped us a lot as a team to go and understand what we needed to do. And as always, start slowly. Just enable TypeScript on your JavaScript. What that means is that you don't need to write you don't need to have TypeScript files and types everywhere in order to already benefit of the basic type checking, because you can just say, please check my JavaScript to see if I have mistakes anywhere or not. And that also means you don't even have to have a build step yet for it, because you don't have to compile your code to JavaScript, right? And that you can do by just basically saying no emit to true, and if that's there, it will not try to compile it. It's just basically a type checker or a linting tool. And as I said, due to the fact that we started slowly and from the inside outside, just do it layer by layer. We did everything in a span of, I think, 4 or 5 months, while releasing new features as well, by just doing step by step. So we first did all the adapters, so we knew what we were getting from the external dependencies, and then moved on to the services and moved our way out. And yeah, for us that worked really, really well. And for me, it would be the best strategy to do again if I have to do it again. This, of course, all not necessary if you start from scratch, then just do whatever. Besides that, we have, of course, learned something, not just based on TypeScript, but just over the years of working on a long-term project, and especially in the Node.js world. I can't really speak for what happens in the Java world per se, because I'm not that active in it. But Node.js just evolves really, really quickly. Like I said, in the 2-year time span that we started and I came back, we started with our lovely callback, which some people always call the callback hell after a while, depending on the developers go into it. But Node.js evolves quickly from callbacks to async waterfalls, which was a thing at a certain time, which basically was pre-async await, just a separate library that did this, to the async await that everyone, well, not, I can't say everyone, but most people really like over the callback hell, and from my personal experience over the async waterfall. But also the way of working of developers, because developers in the JavaScript world adopt very quickly the new ways of working. And if you want to keep up with that, you need to have certain tools in place that enable you to update your projects as quickly as possible. Hence why I think TypeScript is a need for bigger projects that you are working on with multiple people, because it gives you the confidence to actually do it. Besides that, the fact that you are locking yourself in, of course, a little bit with TypeScript, because you are saying this in this function we can only get these kind of values. But due to that strictness, it can give you a lot of benefits that we have encountered. For example, what we currently do in our way of logging, we have just a few. We have an error logging, we have an info logging function, and all of them basically are receiving two different things or three different things: a flow, and a layers, which are both enumerators, and just a message. What these enumerators basically do is they restrict the developer in this way to only specify certain kind of keywords. So of course there's a bit more, but for example, we can are only allowed to use event and then a layer. Where in our layer does this happen? In order to give us the power to make really easy, quick dashboards in Kibana, where we can basically use these as tags in order to make sure that we can identify certain errors that we shouldn't have or messages that we should have. We just want to know how many of them we get. And due to this strict formatting, we don't have the developer A looks in a certain way and developer B in another way. And the moment we want to change something, we have to change it all over the place. So this is has been a big help for us. And surprisingly, we found we found hidden bugs as well in our code. Basically missing parameters on some fields or passing in a value that shouldn't be allowed. These are basically the bugs you don't really encounter in production a lot, or never, or are things that people think are just glitches. And there was even recently a study being done by some students from the UCL, the University of London, and Microsoft together about TypeScript on public projects, and that identified that 15% of the bugs reported could have been prevented by just using TypeScript on those projects. So yeah, it helps a lot. And of course, the major lesson is that, which we could showcase to our managers at least, Node.js can, as we already thought, be just as stable and performant for a use case as a Java.NET API, because we haven't had any issues yet that we would have been able to solve with switching technology stack, basically. And then I would like to thank you for your time.
Thanks for your presentation, Remco. We have a couple of questions that I will switch to the screen. And meanwhile, probably there will be more. So first one is about you were showing the diagram that of the tools you guys using. I recognize some of the patterns definitely, like sidecar. It's the way we do it here, not only in ING, but I think industry wide. But you also mentioned Rethink the B as a choice for data. Why Rethink? Why not some other solution?
Well, Rethink the B came originally from one of the developers that were working on the team. But as I mentioned briefly, we were looking for a connection or a WebSocket supportive database, basically. And we knew we could make it ourselves with MongoDB or whatever database. It's all possible, right, to do it ourselves.
Yeah.
But Rethink.db basically came out of the box with a solution for that already. So we didn't have to do any of the work ourselves.
Okay, clear. So it was just a natural choice done at some point, but later it was kind of fulfilling the needs that you guys had.
Correct.
Cool. And one more, you mentioned also about it's switching to TypeScript was saving time or effort in onboarding new developers. So can you maybe elaborate a bit more on that? So if I suddenly join your team and I don't have a practical TypeScript experience, for example, like do you see also improvement here, or how you guys do that?
Well, TypeScript in essence is still JavaScript. So if you can write JavaScript, then you are able to pick up TypeScript. I don't say you are as quick at the start as you would be in just pure JavaScript, because of course there are the types that you have to take into account, and at the start it's a bit getting to know. But it's a lot easier to feel confident in doing the changes as well in the API, because you get corrected if you do something wrong, basically.
Indeed. That part is definitely clear. That's also kind of part of my question, because what I also see sometimes in big enterprises where people may want to grow in the fields they haven't been exposed before. Let's say you've been a Java dev for years and you want to try some front-end stuff, or maybe other way around. And do you see that it's easier for people with Java or .NET mindset to switch to TypeScript-based API for maybe working in the team, or at least maybe proposing some code improvements?
Yeah, we haven't had that experience myself yet, because all the developers we get on board on our team are most of the time front-end developers or JavaScript developers. But what we hear from other developers that are Java focused, yes, they do see the benefit, because some of us in our team do have some Java background, but not experienced enough, but some, or at least with type strict languages. And the mindset is then there already, because they're so used to doing the types, basically.
I see. Yeah.
They get lost without the types.
Yeah, at some point it becomes like a second nature, indeed.
Yeah.
Great. Again, thanks for the talk. Thanks for answering the questions. The last thing for you guys, I wanted to draw attention to, please find time to look at our tech blog. We've been recently added quite some new content there, and it's not only about JavaScript or front end or that stack. It's all around the tech, including domain-driven design, blockchain. We still do that, and we're doing quite well on this. And yeah, architecture, how you build tools that are reused across a large scale enterprises. So lots of interesting read, and it's quite a lot of fresh materials regularly. So be sure to have a look at it when you have time. I'm sending a link now in the chat. That was it for today. I'd like to thank the speakers once again. It was a great evening, great 2 talks, and hopefully see you next year with another iteration of front-end version of Tech Meetups at ING. Have a good evening and bye.